Okay, in this video I want to show you one of the more advanced tools of this SQL Server Analysis Services plugin. You may or may not be required to know this on your final exam. Your Learning Suite schedule should tell you. Likely not, however, double check with your instructor to be sure. In this tool, what we want to do is compare the effectiveness of different algorithms for predicting key influencers. So let's go to our Table Analysis Tool Sample tab, click in the table, and this time we're not going to use the Analyze tab. We're going to go to the Data Mining tab. Here in Data Mining, in addition to Explore and Clean Data, which you've already learned, we have a bunch of other tools. These are all more detailed versions of the same tools you've already learned. This is kind of the, I don't want to say dumbed down because they're pretty advanced tools, but these are more simplified versions of the tools on this tab. So for example, the Classify tab will let us classify people into a dependent variable that is categorical, like a yes/no value, rather than 1, 2, 3, 4, 5. Estimate is the same thing, but where there's a numeric dependent variable. So for example, we want to classify people as either bike purchasers or not. So we're going to start by using this tab, this tool, and click next again. Notice it looks very similar to the Analyze Key Influencers tool. We're going to deselect ID. This time though, we select column to analyze right here, and we set it to purchase bike. Under parameters, let's ignore this for now. I'll come back to that. So let's hit next, and it has this new screen here that says, what percentage of data do you want to hold out for testing? What that means is we won't, we'll build and train our model. Think of a model like that prediction calculator that has a bunch of scores for each attribute value pair. That's what I mean by a model. So it says we're telling it to hold out 30% of our data to test our model after we've trained it. And by test, what I mean is we'll plug values in and see how accurately it was able to predict yes/no on purchase bike. And since we have that data, we know for sure exactly how accurate we can be. So let's just leave this at 30. Click next. I'm going to call this Classify Structure. It really doesn't matter what you're calling it, but what it tells us down here is a description of the model. Now the structure says which variables am I going to use, and that's something we've already defined, and a model tells us some of the more detailed, it's like an instance of a structure. So the model is what type of algorithm are we going to use to predict in this structure. And this first time through, it's by default, it's selected what's called the decision trees algorithm. So I'm going to change this description to simply decision trees. Whoops. Leave the model name. Actually, no, I also want the model name. That's what I should have made it, decision trees. I'm going to leave it like that. Okay. I want to leave browse model and enable drill through checked. And I don't want to check use temporary model. It's going to store this structure we create in your SQL Server Analysis database. And click finish. So this is using an algorithm different from the one we use in Key Influencers Analysis. In that analysis, we actually didn't even know. It arbitrarily, well, not arbitrarily, but it picked an algorithm for us, and we didn't know what it was. This time through, it's using decision trees, which says, okay, all of the variance in whether they did or didn't purchase bike is first explained best by their age based on this algorithm, which is different. Remember, before it was based on the number of cars they had. Different algorithms will come up with slightly different results. So in this case it says, okay, those who are less than 39, the blue represents those who don't buy a bike and red is those who do. That's one defining factor. Greater than 39. Those who are less than 32 are also very likely to not buy a bike. But those who are between 32 and 39, notice the red yes bar is the biggest on this one. This is my group who is likely to purchase a bike. And after that variable, and only in the case of where they're less than 32, the next variable that matters a lot is how far their commute distance. And it doesn't go through all the commute distance options. It just says, is it equal to 5 to 10 miles or not? This one says not equal to 5 or 10 miles. So in this case, these people are not going to buy a bike. These people are more likely to, after accounting for age first. Anyway, there's some dependency networks. We won't get into this for now, but this is just another view that allows you to see the variables visually that are affecting it, and you can move this link down, and it takes off links in the order of their importance. So age is most important, so it stays linked. Anyway, I'm going to close this out. What we've done now is we've created a model that's living now in the database, a structure and a model. A mining structure says, here's the type of analysis we're doing, here's the variables used, and then the model is an instance of that structure where we pick an algorithm to actually run the prediction. What I want to do is run the exact same analysis again, but with a different algorithm this time. And then I want to compare and see which one was more accurate at predicting whether or not people purchased a bike. So next I'm going to go to my Advanced tab here, and I want to add a model to an existing structure that I've already built. So add model to structure. It says, okay, we're going to browse your SQL Server analysis services and find any structures you've created. And you'll see a few, I think, because I've made a few. Oh no, just this one. It's the first one I've made. It says we found something that you called classify structure with decision trees in it. I say, yep, this is the structure I want to add a model to. It says, okay, now pick a new algorithm. First time through it used decision trees. I can use almost any of these algorithms in a in this classify task I'm performing. So I'm going to use logistic regression rather than linear. Logistic means that my dependent variable is categorical. It's yes, no, rather than a numeric value, which means I would use linear. So I'm going to use logistic regression next. Hit next. In this screen, I'm basically saying which variables am I using to predict, and that means I set them to be an input. Purchase bike. This is the one I'm predicting, so I want to change that one to be both input and predict. Click next, and this time I'm going to just call it logistic regression. Yep, hit finish. Wait for it to run. Okay, notice with this algorithm I get a different view. This is kind of like that analyze key influencers, where it tells me attribute value pairs that favors no versus yes, and it combines them into one model. So having many children means I'm not going to buy a bike because I'm spending all my money on kids. Having many cars means I don't need a bike for transportation. Those are my next biggest indicators. But then having a high income is the largest indication that yes, I will buy a bike. Anyway, you're probably familiar with how this works. I'm just going to hit close. That second model's been created. Let me add one more before we compare them now. So I'm going to go to Advanced, add model to structure one more time. Hit next. I'm adding another model. Notice here's my decision trees and my logistic regression. I'm going to add another model to this classify structure, and this time I'm going to use neural network. This is a slower but often more accurate algorithm, but again, this is just on the average. It doesn't mean it's always more accurate. Change purchase bike to input and predict. Hit next. I'm going to change this to just neural net and finish. Okay, and this gives me a similar view to my logistic regression, and similar results too, although it's not exactly the same. Children, and then cars, and then income turns up third, then commute distance, so it's slightly different. Anyway, now I have three different ways that I've predicted the exact same classify analysis. What I want to do next is create a profit chart that will help me compare how much money I could make depending on which algorithm I use to rank order my customers. So I'm going to click next with classify structure selected, hit next. Now in this case, let's assume that I have some new marketing strategy or a new mailer that I want to send out to customers. Okay, I want to target 50,000 people. It will cost me $5,000 excuse me. Cost me $5,000 to produce this mailer. Or I'm paying some marketing company $5,000 to generate the design and the initial copy. But then it's going to cost me $3 a piece to print it out and mail it, but I'll make $15 on each person who actually goes through and makes a purchase. Well, if these are bikes, that's probably going to be something much larger, so I'm going to change that to 1,500. Let's say I have high-end bikes. Okay, so I'm going to click next now. Yeah, next. Back. Finish, actually, is what I meant to do. Okay, let me scroll down. What I have here is a graph that shows me each of the algorithm's predictions. The blue line here is my no model random line. So this means I'm just randomly selecting people from the population to send the mailer to. Here's how much money I make. I make more money, obviously, as I send out more and more flyers. So the relationship's positive. Each of these other ones show me how much more money I would make if I were to rank order my customers based on that prediction. And for example, if I only mailed out to 50% of the population, the 50 who are most likely to purchase, then this purple line right here, the neural network model, that would make me more money than anything else, a value of 24,421,000. If I used logistic regression, I make a little less money, 22 million. Or this one, decision trees, 21 million. Okay, if I mail out to the entire population, I'm going to make the same amount, right? Because I'm not rank ordering them at all. It's going to be the same for all of the models. But notice how even though neural network is the highest at this point, it's not the highest all the way through. At this point, logistic regression bounces up above it, and here even decision trees bounces up above that one. So, pretty incredible tool that you can actually put a dollar figure behind how accurate each of these things is at predicting your customer value. So this is super useful because, again, even though neural networks are supposedly more accurate, they won't always be. It's very customized, it's very context dependent on the actual data you have in your area. So this is a great exercise to perform in a data mining task before you simply trust any one of these algorithms to predict consumer value or something else like that. Anyway, that's all for this video on profit charts.